Okay, I welcome you guys to my new tutorial about polynomial long division. Okay, before we start off with some examples and how it actually works, I want to cover the topics where you actually need polynomial long divisions. And it starts off, we have here several points where we will need it. We will need polynomial long division for solving equations. For example, if you have higher order polynomial equations like a polynomial of a degree of 3, for example, so something with x to the 3 and so forth, you will be needing this. There are actually real methods to solve them without polynomial divisions, but it is a lot faster, and you do not have to remember these complex formulas that you need for solving the polynomial of third degree of the polynomial of fourth degree. So we will only do the easy way first. I will cover them later on. Okay, now let's start off. We need them for solving equations. We need polynomial long division for factorizing polynomials. These both are very strongly related to each other because of the fundamental theorem of algebra. This is a very fundamental theorem, and actually we won't prove it here. I will just often use it because it states that any kind of polynomial has as many solutions as its degree, and if you have all the solutions, you can factorize them out. And very important too is that these solutions should be complex numbers, but I suggest here for the completeness of the video, but I won't cover this topic of complex solutions right now, maybe later on. And the third topic where you will need polynomial long division is the topic of approximations. We will have some examples here. Now let's look how it actually works. Okay, let's have a look at the first example. There's a pretty long example. I've constructed a polynomial of third degree, x to the 3 plus 2x squared minus x minus 0 equals 0. So first of all, we see that this is a normalized polynomial of third degree, but that's just for you to know that this is normalized as well as we did for the quadratic equations. Now what do we do next? We solve for, so this is our task, solve for x or find all solutions. Okay, finding all solutions. This is our topic, but as you look at this, this is not a quadratic equation. If this part would not be in there, you would have a quadratic equation, but actually, like it's written down here, it's a cubic equation, and we cannot solve that with very easy methods. Now there comes the first step of polynomial division. It's the step of guessing a solution. Now the idea is to look always at this number, the last constant term, and it is actually known, it's a fact, that this number is always a product of the solutions. For a polynomial of third degree, you will have to add in here a minus. It's x1 times x2 times x3, sorry. And actually, if you go to fourth degree, this will be a plus. For fifth degree, this will get to be a minus, but it's always the product of the solutions. Now what you can do is just we assume here that your solutions are integer numbers. This is very important. Then you can rewrite this as a product of integers. Okay, and it's pretty easy. You could write it as minus 2 plus 1 minus 1, and this would give you all the solution. This would give you the equality, or so you have 2 has to be equal the product because of the minus going away. Now if you try minus 2 as a solution, okay, I just say this is solving the solution. Actually you can rewrite this as minus 2 times 1 times minus 1, and I will just try to see if this solves the equation. Okay, just enter these values into your polynomial, and you get minus 2 cubed plus 2 in brackets minus 2 squared minus 2 equals 0. So you get the minus 8 because it's cubed, the minus still stays there, and it's 2 times 4 because this minus vanishes because of the square. We add 2 and we subtract 2 again equals 0, and actually if you calculate this you get 0 equals 0, which means that your x1 equals to minus 2 is a true solution. Okay, now knowing this, we will need a new idea, and this idea is written down here. If x1 is a solution of the polynomial, then we can divide the polynomial with the factor, this is very important, x minus x1. Maybe you remember from the theorem of Vieta that I already shown that we always had this kind of factors in there, and actually this is the general case. You can always rewrite any polynomial as a product of things looking like this, x minus x1, where x1 is a solution. It may be real or it may be complex, so I won't cover the topic of complex solutions, just mention it here. Okay, now if we apply this idea here, we can say that x cubed plus 2x squared minus x minus 2 divided, I will use this notation, divided x plus 2. I don't often use this kind of notation, only when doing polynomial division. Else you write, when dividing, use the fraction representation of that. Now, how do we go on? So the first thing that you have to do is to look what has to be here, okay? And what you do for that is you take this x and divide this x cubed with x. So you get x cubed over x and you get x squared. So why is it good for? Because we will multiply out these things, okay? X squared times x will give you x cubed plus x squared times 2x squared 2 will give you 2x squared. Okay, we have written down this. Now what you do, so this was the step multiply. Now what we do subtract. Okay, we subtract this line from this. We get this will be subtracted and give you 0, and plus 2x squared minus 2x squared will give you 0, 2, okay? Sometimes I tend to write in here some brackets and a minus to remember myself, but actually you don't need this because it's analogous to normal division. Okay, now that got away, we got rid of the part here in front. Now let's look at this. We write this down, minus x minus 2. Now again, we have to divide this by x, by the leading coefficient, by the leading power here. Okay, it's x. We do not divide with 2, we do divide with x. Okay, minus x divide over x here will give you minus 1. So we multiply out minus 1x minus 2. Okay, now again, remember we have to subtract. So this is minus x minus minus x will give you 0. I wrote this this line here, and minus 2 minus minus 2 will give you 0, 2. So we have totally solved the equation. We have no remainder here. Okay, so this is x squared minus 1. So what can we do with this? The result is that x cubed plus 2x squared minus x minus 2 will end up to be, if you divide with x plus 2, you end up with a more simpler equation, x squared minus 1. So this is actually a quadratic equation, and you could solve it now. So this is the step. You first guess a solution. Then you divide with the linear factor x minus this solution that you have, and you get a simpler equation for. Then it's actually always, if you divide a cubic polynomial with a linear polynomial, you will get a quadratic, so the degree is reduced by 1. Now this statement can be rewritten as x cubed plus 2x squared minus x minus 2 is equal to, we open the bracket, this is this part, I just multiplied out with x plus 2, is x squared minus 1, we'll close the bracket, multiplied with x plus 2 in brackets. Okay, these kinds of ways. So what we actually did is we guessed one solution and found a simpler representation of our polynomial. Now we can solve for this part with the zeros, and actually you can see them maybe. It's plus minus 1. Okay, plus 1 squared minus 1 will give you 0, and minus 1 will give you the same. So these are the other solutions. You could have just guessed them too. Okay. Now I've written down here the steps. So you have this factor, as this is a product of two polynomials. This is a linear, this is a quadratic. You can say that this can be 0 or this can be 0. If this is 0, we get the solution that we guessed, and if this is equal to 0, we get plus minus 1. Okay, these are the full solutions of the system. So we found out what we wanted to find out. Now here comes a good question. What happens if I divide with something that is actually not a solution of this polynomial? Okay, x minus some number. So I have rewritten this to minus 2. We know that the polynomial above can only have 3 solutions, and they are plus, minus 1, and minus 2. So, and this actually would correspond to a 0, which is 2, because it's x minus x. The solution. Okay, this should be 2. Now let's just check this and divide this polynomial. So how do we do? First we divide this part with this, x cubed over x, we get x squared. We multiply out, we get x cubed minus 2x squared. Okay, now we subtract this line from this. X cubed minus x cubed will give you the 0. 2x squared minus x squared will give you a total of 4x squared. And now I wrote down everything what was left here, minus x minus 2. Now our next step was to divide what is left here, the 4x squared, with x. Okay, here I've written it down. You get 4x squared over x, you get 4x. Just multiply this out, you get 4x squared and minus 8x here. Okay, now subtract again, you get 4x squared minus 4x squared, which will give you a total of 0x squared, and minus x minus 8x will give you what? Will give you plus positive 7x minus 2, because it's left here. Now our last step is here. You can look at this. We have to divide 7x by x. We will get 7. Okay, and we just multiply this out. We get 7x minus 14, and now here again 7x minus 7x will give you a total of 0x, and minus 2 minus 14. Oh, I've done here a little error. This should be minus 2 plus 14, so it's actually 12. Sorry for this error. It's actually 12. Sorry. Okay, it's 12. Okay, I write this like this. Okay, it should be 12. Now this part, these were all dividable. Okay, now we've got something left. This is the remainder. This is 12 over x minus 2, so we have to write it down because we couldn't divide 12 with this, so we write it down, and this is your final solution. Now what can you do with this fancy thing? It looks some kind of strange, but actually it gives you a good idea how to approximate this left hand side by the right hand side. Okay, if you take very large numbers, okay, then you can say, okay, here you will get something very large, but this will be 12, let's say 1 million or something. Then this number 12 over x minus 2 will be very small and not significant if you are in very large numbers. So what this says is that the right hand side equation, So this is actually function, if you would like to say this terminology. This function can be approximately be equated with x squared plus 4x plus 7 with a very, very small additive part. But if you go for large numbers, this is not relevant anymore, and you can use this kind of representation for that, okay? And that's it. Now let's go to the next example. It's a very, very short example, but very, very interesting still. And now I will divide with a polynomial of higher order. So we only had x minus something, and now I will do just test the method, and I will try to divide the polynomial with x squared minus 1. Actually, you know, this was the part which was left, because we showed that this is equal to x squared minus 1 multiplied with x plus 2. So this part divided with x squared minus 1 should give you x plus 2. Okay, and let's just check this. How do you do that? The same method. You always take this number and divide it by your highest power, okay? By all what is here. So you have here x cubed over x squared. This will grant you an x. So now multiply out x. You get x cubed minus x. Here we have written down. Now you just subtract, okay? X cubed minus x cubed will give you 0, and this minus x and this minus x will cancel each other. Okay, we have minus x minus minus x will give you minus x plus x equals to 0. So what is left is 2x squared minus 2. Okay, now again we divide this with x squared. We get 2x squared over x squared, which will give you a total of 2. Now you multiply out 2x squared minus 2, 2x squared minus 2, and you see this and this are equal, and they will give you 0. Now what you would have to do is solve this for its zeros, okay? If you see it, this is pretty easy. If you plug in minus 2, you will get another solution of this equation, okay? So the steps are pretty easy. So what you do first is you try to guess a solution, then you divide with a linear factor, so x minus the solution, and close the bracket. Then what you do is just divide this with that, and you get a number, multiply out, you get this, then subtract, then see what's left, and then do this again and again. This is just like normal division. Okay, now our last example is, okay, I had always something with an x and some number. Now I will do a much harder division with x squared plus 2x minus 1. Okay, it looks harder, but actually it is not. What we do here is actually you look again, this and this, you have to divide the x to the 4 with x squared, you will get x squared. Okay, multiply this out, you get x squared plus 2x cubed minus x squared. Okay, here what's written down. Now subtract, you get x to the 4 minus x to the 4 is 0. 6x cubed minus 2x cubed will give you 4x cubed, and minus 7x squared minus minus x squared will give you minus 6x squared minus 8. Okay, now let's divide again, because we see we have our x to the 3 still here. We divide 4x cubed with x squared, we get 4x. Okay, see this here, we get 4x. Now multiply this out, 4x squared. So you see we do this because we want to have the same thing, so this is falling out of the equation. We do multiply out here, we get 4x cubed plus 8x squared minus 4x. This, now you see this and this will cancel. Minus 6x squared minus 8x squared will give you a total of minus 14x squared, and minus 8 and minus 4x cannot be subtracted, but this will become a plus for x, and the minus is kept with us. Now our last step is we will divide minus 14x squared with x squared. We will get minus 14 because it's minus 14x squared over x squared. This will actually give you 14. You multiply out minus 14x squared minus 28x, and we add. Okay, what a jumble did I do here. We get plus 14. Sorry for that, and now I will correct this here in the bottom too. So this and this will cancel each other. We have 4x minus 28x will give you 32x, and minus 8 minus 14, what will this give you? Minus 22, right? Minus 22, and I will correct this in here too. This will give you minus 22. Okay, now this is our reminder. This over this. So we write this down, and this is the total equation. So just to conclude, or to put everything together, so the steps are pretty easy. You just have to do several equations. But the idea is simple. First, guess a solution. This is your first step. Then what you do is divide with the linear factor. So x minus the solution. In brackets you divide. And in dividing you have to remember to divide x. So the first part with this. And then just multiply out. Then subtract. And look what happens. Okay. This is just a step that you repeat all the time. It's an algorithm. Okay. Now, for my part, that's it with this video. I hope you liked it. I hope you understood the polynomial division. I know it's very confusing at the first moments, but if you just repeat doing it, it will get so much clearer, and it is just easy, okay? I hope you like this video, and I'm just stay tuned because there are many other videos to come. See you guys.